Hey, welcome back. So as you probably realized by now, I love messing around with old programming languages, and I've been playing around with Pascal recently, and as I've been playing around with it, I've realized that it's had a much larger influence on both JavaScript and TypeScript than it gets credit for. And in this video, I'm going to show you why. So interestingly enough, as I was coming to that theory that Pascal's had a huge influence on JavaScript as a language and modern TypeScript, one of the things I was listening to was an interview from Brendan Eich. And if you don't know who Brendan Eich is, he is the guy that created JavaScript in the first place when he worked for Netscape back in the mid to late 90s. Now, in that interview, one of the things that I thought was really interesting is Brendan said, actually, one of his big heroes was Niklaus Wirth. Now, if you don't know who Niklaus Wirth is, he is the guy that created Pascal in the first place back in the late 60s, early 70s. And that's an interesting story in itself because Niklaus was working on the late Algol languages, and they were sort of coming up with what was going to become Algol 68. Niklaus had a bit of a disagreement in the direction, and then really he took Algol 60, evolved it into Algol W. I'm assuming the W stood for Wirth, but I don't know. And then that Algol W then eventually became Pascal, and I think it was released around 1969, but I'm not exactly sure. But then Brendan in this interview was like, yeah, Niklaus Wirth is one of my great heroes. But then, when we look at one of Brendan's talks on the history of JavaScript, and he talks about the influences of the various languages on JavaScript, he doesn't really call out Pascal. And in fact, he doesn't really call out C either, which is really interesting because when you listen to the history of Brendan, he started as a Pascal coder and then he moved on to C and he spent all his time coding in C and Pascal and C++. But yeah, when we look at the history of the languages, he's really calling out kind of Java and Awk. And that doesn't really make sense because when I mess around with JavaScript and when I mess around with TypeScript, I feel the influence that Pascal has had on those languages. And I'm going to go through that with you. So if we look at this chart here, I sort of absolutely get Perl scheme, hypertalk, and self. And I'm not going to go into that. But I think if you're going to call out Java and Awk for syntax and functions, then I think you really need to call out Pascal and C because I think the C syntax is really dominant in there, but Pascal is really dominant as well, certainly for things like functions and types, etc. And in this video, I'm going to really show you that, and then we can see if you agree with me or not. Alrighty, to make this really interesting, what we're going to do is go back to sort of early versions of JavaScript. In fact, we're going to code it up and get it working in Netscape Navigator 3. So to do that, first thing I'm going to do is open up Visual Studio Code. I'm going to code ourselves up a very quick index.html. We're going to see that working on Netscape Navigator 3. And then what we'll do is we'll start adding the JavaScript elements against that early browser. So I'm not going to totally follow the conventions of the day and use all the uppercase shouty stuff. I'm actually just going to be super lazy and then just use lowercase as normal. So I'm sure a lot of you are going to be going, no, that's not how we would have done it back in late 90s or whatever. And that's fine. And I don't really care. This is really just to get something up and running quickly. So we've got our head and title there. And all that's going to say is hello Netscape. And then what we're going to do and put in the body is a simple h1 tag, and then we'll say hello world. So I'm going to save that. You can notice I've got a Docker file here. I'll explain why in a second. So I'm just using a sort of static Go website Docker instance. And then what I'm doing is going to copy the contents of my public folder. So that index.html that we just created there is going to get copied into serve HTTP folder. I'm using a service called fly.io to deploy that. A lot of you will be saying, you could use Code Sandbox, etc. But then I don't like some of the surrounding HTML it generates, and it's going to break Netscape Navigator 3. So I'm just going to manually do this. If you want to do what I'm doing, you can follow the instructions on fly.io. So now that I've sort of got my site, what I can do is I can just deploy that using fly deploy. Alrighty, as you can see, that is now deployed. And actually, if I want to open up that site in a regular modern browser, I can do, but it's just typing in fly open. So I'll do that. And then as you can see, I've got this simple hello world. So what I'm going to do is I'm going to copy the address, which is donhill1885.fly.dev. And then I'm going to use that to open that in Netscape Navigator 3. So to do that, I'm going to open up a site called oldweb.today. And as part of that, you can see I can select versions of old browsers that I want to run. So technically, the first version of JavaScript, I think, was running on a Netscape Navigator 2 when it was called LiveScript. The first version that I can use here is Netscape Navigator 3, which is why I'm using that. So it's a slightly later version, but it's kind of close enough for our liking. But what I can do within that is you can see it's got a couple of options where you can sort of browse live web, or you can browse the archives using all the time machine stuff. So you can see at the moment it's sort of defaulted to GeoCities. So if you want to go and look at old websites, you can just do that, and you can browse around. And so that's GeoCities back in 1996. You can click around and get an idea of what the web was like back then. But we're not going to do that today. What I'm going to do is I'm going to paste in the website that we just deployed to, which is this donhill185fly.dev, and then I'm going to click on browse live web, and then I'm just going to hit reload here. And as you can see, it's sort of loading up an old version of macOS. It's got Netscape Navigator 3 in there. And there's our site, Hello World. So this is the exact same thing that we coded. So here's something that we've coded in 2022, with there's no JavaScript in it at the moment. We'll do that in a second, but you can see it now renders fine in old Netscape Navigator. So, gotta love the web. So what I'm gonna do now though is we're gonna start introducing some elements of old JavaScript, make sure this works on Netscape Navigator, and then I'm gonna start to show you the influences that the Pascal language really had. So let's come back into Visual Studio Code for a second. And then what I'm going to do is I'm going to put the script tag here. Now, I'm not going to bother going type equals JavaScript and all that sort of goodness. And I'm not going to bother putting all the HTML comments, which is really fascinating how Brendan did that back in the time in order to have browser compatibility. We're not going to do that today. We are just going to, because we're looking at the influences of the Pascal language. So I'm just going to do a hello Netscape. I do another fly deploy. And then that will take that version that we just created, and then it'll push that up to the web. And then what we'll do is open that up on Netscape Navigator and see what happens. Okay, so now that that's deployed, I can come back into my Netscape Navigator, and then I'm just going to hit the reload button in Navigator here. And then you can see there, JavaScript alert, hello Netscape. So that's kind of cool. We've got JavaScript working in an old version of the browser. But let's talk about the influence a little bit more. So rather than doing an alert, what I want to do now is I'm going to switch this out to write into the DOM. So I'm going to do a document.write, and then we'll say hello DOM. And then for a little bit of fun, we will also do a document.WriteLn, and we'll say hello WriteLn. And then we will do another document.write, and we'll say hello. And yeah, we won't semicolon terminate that. We'll talk about that in a second. And we'll say hello world. And then we'll do another fly deploy. Okay, now that that's deployed, I'm just going to open up my browser one more time. And then what we'll do is we are going to hit reload here. And there you go. I've got my hello world with the LLLL that's in our body. And then as you can see, I've got hello DOM, hello WriteLn, hello. And actually, it's all in one line. And if you think about the write and the WriteLn for a second, then, new line characters don't mean anything in HTML, so nothing really happens there. But if I go to a view document source for a second, what I want you to see there is, and this is so cool, right? View document source, 1997 version. There's HTML head, title, hello Netscape. There is my document WriteLn. So you can see I've done a document write, so it's put that there. Then I did a document WriteLn. It's inserted the new line character here, and then a document.write with the hello, and then there's my body, right? So, there you go. There's the DOM up and running back in sort of 1997. Now, there's a couple of things that I want to go through straight away. Let's come back to the code for a second. So the first thing that I would say is this is very Pascal-y. This is very Pascal-y. Where do you think write and WriteLn comes from? It's Pascal, right? And then here, this script here, that's very top-down programming, right? And that's one of the things that Brendan Eich was wanting to get across, right? That JavaScript really was a top-down programming language. And if we look at top-down programming languages of the day, we're talking about C and we're talking about Pascal. You know what isn't a top-down programming language? Java. Java is not a top-down programming language. It's object-oriented, it's bottom-up, right? Because you're focused on classes, etc. But top-down is you're starting from this top and then you're just, expanding out, right? And you see that here. So what we're going to do now for a little bit of fun is I'm going to write something equivalent, but what I'm going to do is do this in Pascal, and then we can decide what the equivalence is. So let's kind of come here. I'm using a tool called Free Pascal to do this. It's already pre-installed on my machine. I'm not going to go through the installation, but you can go look that up on the web and then be able to do it yourself. I might do a video on Pascal at some point, but who knows, right? So the first thing I'm going to do is I'm going to create a new directory and we'll call it hello Pascal. And nice and simple. We'll cd into that. And then what we're going to do is we will create a new file called hello.pp. pp is, I've got to stop saying the words pp, but pp is the file extension for Pascal. So we'll just create a new file there. And then what we'll do is do a code dot here. I've pre-installed Pascal extension, so that is going to give me all of the nice IntelliSense and all that good stuff. But again, you can decide whether you want to do that or not. So let's create a very simple Pascal program. So to do that, we will do program. So we have to start a program with the word program, and we'll call that hello. And we have to semicolon terminate that. And then every Pascal program has to have a begin and an end. And in order to end a program, the final end has to be completed with a dot, as you see there. So that is, again, that's a sort of top-down structure. So in Pascal, Pascal doesn't represent blocks as brackets, as you would see in languages like C or Java, etc. It uses begin and end. And by the way, that sort of begin, the end, the program as well, that is all coming from Algol 60, and then that's been evolved. So it's not particularly Pascal-y, but, obviously Nicholas Veert has obviously taken the language and moved that further on. Okay, so what I'm going to do now, I'm going to do a quick hello world, and I'll do this with the WriteLn command. We'll just put hello world. I will save that. And now to compile that, all I need to do is type in FPC, which stands for Free Pascal Compiler, hello.pp. That will then do the compile. And now, as you can see there, it's generated hello.o, but it's created my executable. So if I do /hello, and you can see it will return hello world. So I want to come back to this for a second. Look at this, and then we will look at the script in JavaScript that we created. Program, which is indicated maybe script, code block, right? Which is, I'm running in a top-down fashion, and then WriteLn hello world. Yep. And by the way, that semicolon is optional in this case, and I'll go through that in a little bit in a second. So let's compare this to my index.html script program maybe. This is essentially a code block, but underneath here, document.write, WriteLn, write hello. And by the way, Pascal is not case sensitive. So if I wanted to, I could come back into my Pascal code, and then I could just do WriteLn like this. I could even do a write like we saw before. So I could go hello. I said before it's statement terminated, so I must have semicolon here because it's not the last statement. And then I could do a WriteLn of hello world. And then if I wanted, I could then go hello. Let's take away that final semicolon. Let's come back to here. What we will do is we will compile it again. So you can see that all worked. And run hello, and you see hello world. Then you get my second hello world. You've got the new line now, and then hello. And again, let's compare that back to my original index.html. WriteLn, write, semicolon, semicolon, no semicolon. Because guess what? JavaScript is statement separated. It is not statement terminated. Java's statement terminated, C# statement terminated, but Pascal is not. And it was one of the first languages. I mean, obviously Algol 68, Algol, etc. is the same, but Pascal is not a statement terminated language. So, you know, WriteLn, if you're not saying that there's an influence from Pascal there, then that's crazy, right? Because write and WriteLn isn't really used by any languages before that. So the influence from Brendan Eich has got to be coming from Pascal in this particular case. Second thing is you can't say that statement separation is being influenced by by C or Java, because guess what? They're statement terminated languages. So really, it's the statement separation is being influenced by the Algol languages. You know, please see used to code in Pascal. It's coming from there as well. And then actually, even if I wanted to prove my point, I could create the same thing in Java. So let's do that for a second. So we'll just come back here for 1 second. We'll create a new directory. We'll call it hello Java. We'll do cd hello Java for a second. Okay, and then what I will do is we will create a new file called touch hello.java. We'll do a code dot. In the hello Java, we'll create a new hello world. We'll call it hello Java. Then we will do a public. Yep, that will do. That's about the second time in my life that GitHub Copilot seems to have been useful. So there we go. Anyway, let's just save that for a second. Let's come back into here. Let's do a Java hello Java, which is going to quickly compile my hello Java code. And now if I type in Java, and I think the class name was, what was the class name I called it again? Hello Java. So if I go Java, hello Java, you can see it comes back with hello world. Point is, that's a statement terminated. If I remove that and then just do a Java hello Java, I get an error, right? Whereas I don't get that error in JavaScript. So Java is statement terminated, not statement separated. Java is case sensitive, right? If I put a T here for a second like that, and then do a Java here, I'm going to get another error because it's like, I don't understand any of this. Whereas if I let's come back to Pascal, it doesn't care. As you've seen, I switched from capital W, whatever. I could put a T here. I could put an E here or an E here. It doesn't care if I then go and compile my hello Pascal. So fpc hello.pp and then run hello. You can see it still works because it's a case insensitive language. So now that we can see that Java is a case sensitive language, as is C, and we can see that Pascal is a case insensitive language, what is JavaScript? Well, technically JavaScript is a case sensitive language, but it's a little bit more complicated than that. Let me show you what I mean. So what I'm going to do is I'm just going to change this to document.write. Hello, WriteLn there. We are going to do a fly deploy. So that'll take a few seconds to do that deployment. Once that's deployed, what we're going to do is look at how that looks in a modern browser, but we'll also look at how that works in Netscape Navigator 3. So it'll take a few seconds to get this deployed. So if I do a fly open, so as you can see, there's no errors, but I just told you that JavaScript is a case-sensitive language, and it is. But what actually happens underneath the hood, which is the same with HTML, etc., is the browser is compensating. So although JavaScript, the language, is case sensitive, what's actually happening is the browser is trying to compensate for things that get wrong, and therefore it's just going to let that through. That's what's going on underneath the hood. It's not as strict. But if I come back into Netscape Navigator, let me hit reload here for a second. And you can see it's came back with document.write RLN is not a function. So back in 1997, I think that was, you can see that the browser is less strict. It's following the language quite strictly there. It's saying, yeah, JavaScript, that is definitely a case-sensitive language, as you can see there, and it's coming up with errors. But as time has gone by, as browsers become more advanced, they're really just compensating for mistakes that script language writers are making. So it's not that JavaScript isn't a case-insensitive language like Pascal. It just happens to be that the browsers are compensating for that. So you can kind of see the Pascal elements there, but I don't think they were sort of intended by Brendan Eich. So what I'm going to do now is I'm going to actually do a couple of functions in JavaScript, and then we're going to compare that to Pascal. So what we're going to do is we're going to have a function here. We'll call it sum. We'll put A, B, and then what we will do is we will return A plus B. So very simple function. And then what we're going to do here is we'll just write out the result of that. So what we'll say is sum 1, 2, and off we go. So that's going to take sum, it's going to add 2 to 1 up there, and then it's going to output the result using a document.write. So if I do a fly deploy, that'll take a few seconds, and then we'll see how that looks. And I mean, it's going to be fairly simple. So whilst that's doing that, what we're going to do is do the equivalent in Pascal. So let's open up Visual Studio Code. We'll go to Pascal, and then we'll write the exact same thing. So the first thing that I need to do is I'm going to type in the word function. Is this starting to feel familiar yet? Right? And I know you're going to go, oh, wow, this is, it got it from the language awk, but come on, right? Pascal is the first language that uses the word function. We can see the influence. Now, there is a massive difference between Pascal and JavaScript, and that is JavaScript is dynamic type, where Pascal is strongly type or static type. And you're going to see that in a second. So what we will do here is we'll put in the A, but then I've got to put in colon integer. So what you're seeing here is I need to annotate the types. I need to specify what the types are. So I'm saying A is of a type integer, and then I'm going to put B, which is of type integer. So A is an integer, B is an integer, and then I have to specify the return type, which is of integer as well. And then I need to do my begin followed by an end. And then in order to return the result, this is where Pascal is a little bit different from C syntax. So rather than doing a return, what I have to do is assign the value to the function name. So in this case, the function name is sum. So I would do sum colon equals, which is the assignment. In Pascal, I'll do the A plus B. I don't need that in there. And then we'll save that. And now if I want to write that out, I can do a WriteLn. And we can say sum 1 plus 2. If I come back into my terminal for a second, and then if I do an fpc hello.pp, that's done that compile. We'll do hello, and you can see it's done the sum, which is of 3. So what I mean by strong typing, so if I provide something other than an integer there, the compiler is going to freak out. So if I go Fred, and then try and do a compile, you can see got constant string expected small int. So it's already kind of freaking out and saying this type here is not the same. And if I put in Bob there, Did the same thing. You can see I've got the same error again. So, you know, it's not like JavaScript where I can pass in a string there and it's going to work fine because it's going to work out what the types are. That's not what's going to happen in Pascal. Strongly typed, I've got to match the types. In the meantime, my JavaScript should have deployed, come back to my Netscape Navigator, do a return. You can see it's came back with the 3. So, and then it's got the hello world. So let's come back into Visual Studio Code for that for a second. And you can kind of see function AB return A plus B. If I wanted to, with JavaScript, I could pass in Fred and then Bob, because JavaScript's dynamically typed. It doesn't care. It also does the operator overloading on the plus, so it knows how to concatenate these two things together, and then you'll get Fred and Bob concatenated. So if I were to do another fly deploy, and then what I can do is if I just hit reload here, you can see it's done a concatenation of Fred and Bob. So JavaScript does not care, it's dynamic typed, whereas Pascal is strongly typed. Now, that is the same for C and Java. They're both strongly typed languages as well. So, you know, there's no real influence coming on there. So I get the point about the influence of functions, etc. being awk, but I want you to follow this for a second, right? Because actually, let's come back to our Pascal for a second. What I'm going to do here, let's come back into hello.pp. And what I'm going to do is I'm going to take this function here. And then what I'm going to do is I'm going to smoosh Pascal with C. And what you're going to end up with is JavaScript. It's gonna be odd, but you'll see what I mean. So I'm going to take this function, all right? I'm going to come back into Visual Studio Code for a second. So the first thing I'm going to do is I'm going to get rid of the begin and the end, which is all very Pascal, and we're going to turn that into C-style code blocks. So to do that, we will just put an open bracket here. I'm going to get rid of that end there, and you can see it's kind of opened up this nice little space here. So I'm going to sort of take the sum, I'll get rid of that end block here, and then we will place the sum equals there. So I've now got C-style code blocks. It's looking a bit more JavaScript-y now. Now, as we know in C, it uses return to return from a function as opposed to doing variable assignment to the function name that Pascal does. So what we'll do is just get rid of that sum equals, and we'll put the word return there. That's kind of cool. But actually, I want you to think about this for a second. Let's just get rid of that semicolon. This is kind of TypeScript-y, right? I mean, if I took this here, and then if I just copy what I've got here into TypeScript Playground, now it's given a bit of an error, a bit of a squiggly, because it can't find the name integer, and that's because the data types in JavaScript, integer is not a data type. As we know, it's number. So if I was to just replace this with number, and number, and we change that semicolon to a comma, you know, we're being more C-like, and I change that to number, and then I do a console.log, and we do a sum12. Let's just save that, and then if I just run it, you can see it's came back with 3, and that is essentially TypeScript. So if I get rid of the number, because guess what? TypeScript supports type inference. Do a run here, you can see it works. And again, if I just undo that back to number again, you see I'm fully annotated, and then I can run it again. So I want you to think of that for a second, right? Because this function sum A number B number, this postfix type annotation style, that is completely Pascal-y. Function sum A, I mean, I could turn that to being number. I could turn that to being a number. I could turn that to being a number. I could make this a code block. I could make this a code block here, and then I could turn that to a return. And I've got TypeScript. TypeScript, if you think about it, is completely influenced by Pascal. So type annotations, specifically postfix type annotations, i.e. the type is declared afterwards, as opposed to in something like Java or C. So if I come back to Java for a second, you can see that if we were to do int sum equals 1 plus 2, you can kind of see that I'm specifying the type, because Java is still a static language. I'm specifying the type pre the variable declaration. So it's pre as opposed to post. So that is the big thing that TypeScript is doing, which is these postfix type annotations. Where does that come from? Comes from Pascal. Where does type inference come from TypeScript? It actually comes from the ML language, in fact, specifically standard ML, and it uses type inference algorithms so that you don't need to specify the types in the same way that TypeScript is done. So TypeScript has got this massive influence from ML, it's got this massive influence from Pascal, which makes sense because Anders Hallsberg, prior to doing TypeScript, did C#, and prior to doing C#, he did, drumroll, Turbo Pascal. So Anders Hallsberg has that same sort of influence that Brendan Eich has got as well. So he's brought elements of Pascal and things like annotations, etc., into TypeScript, and therefore is influencing what modern JavaScript becomes. So I think that's super interesting, but you're really hopefully starting to see the influence there. So syntactically, we talk about Java. So if I come back to that chart for a second there, it's saying Java is the influence for syntax. If we look at it realistically, it's Pascal and C combined together, and there's elements of Java in there. So like some of the library stuff, like the math class, for example, from Java is almost identical to the math library in JavaScript. The number type, that's definitely coming from Java, that's for sure, right? So, this idea of number being your base object and your integers, floats, and all that coming underneath that, that's definitely a Java influence. Whereas, Pascal and C# are all sort of integers, floats, etc., is kind of normal. So I would be arguing that you could take Pascal with a C-style syntax, and that's much closer to the JavaScript syntax than Java is. And then I would also argue that when you bring in the influence of Anders Hallsberg and TypeScript, the fact that you've got postfix type annotations, the annotations are very similar to what you would do in Pascal. The fact that TypeScript is bringing in strong typing in the same way as C# has strong typing, and the same way as Pascal has strong typing. In fact, Pascal was one of the first, if not the first, strong typed language in that sense. So strong typing is a sort of key part of Pascal. You can start to see that influence really coming in TypeScript. So I think Pascal is really a sort of modern part of that. So I would argue here syntax mainly C, not Java. Okay, so the next one I want to cover is variables and the var keyword. So to do that, what we're going to do is going to come back to the Pascal code that we had a second ago, which sum two numbers, and we're going to extend that a little bit more. And what we're going to do is add a random number. And by adding a random number, then that means we can kind of use a variable and see what that looks like. So I'm going to add a new function on here, and it's going to be called add random number. And it's going to take in an integer, which is fine. And then it's going to return an integer. So we will use our type annotations again. And then now here is probably the key thing about variable declarations in Pascal, which is at a function level or even at a block level, you need to declare your variables in advance. It's not like JavaScript where you can just, put your vars anywhere where you like. You need to put it at the start of your code block. So in this case, for a function, if I want to use a local variable, like I want to say num, then I need to declare my number in advance. So I will say var num integer. Now, stylistically, if I've got multiple declarations, then I would say num2 equals blah, blah, blah. And therefore I would have a list there. But I've only got one here. So I put my variable declarations up front. And then I need my begin, and then I need my end, which would be semicolon terminated in this case. So in order to generate a random number, one of the things I need to do is I'm going to use the function called random. But if I don't call a thing called randomize in advance, what it will do is generate the same sequence of random numbers every time. So in order to have a different random number every time, I'm going to call randomize. So we'll just do that. And then what I'm going to do is I'm going to generate a random number from 1 to 10, or it could actually 0 to 10, and then assign it to my variable num. So all that's going to do is generate a random number that's different every time. And then what I'm going to do is I'm going to assign the result to the function add random number, i.e. return it. So I'm going to take the incoming number A, and then I'm going to add the number to that and then return it. So that's how I'm going to add a random number. And then what I'm going to do here from the sake of laziness is my sum. I'm just going to add random number here, and then we will return that. So what we will now do is take the sum of 1 and 2, and then generate a random number, add it together, and we'll get the result. And what I'll do is just compile my Pascal, and then if I type in hello, you can see it generates 12. And then every time I run this, it's going to generate a different sum because it's summing two numbers together and then it's using a random number. It seems to have a preference for the number 12 and number 6 at the moment, but that's fine. We'll worry about that another day. So that's working, and that's kind of very Pascal-y. Let's come back to the code for a second. So let's look at this. Var number integer, right? That var statement, that's very JavaScript-y. Yeah, it's very JavaScript-y indeed. In fact, if we were to go and rewrite that exact same function, but this time do it in JavaScript, let's see what that would actually look like. So what I'm going to do here is I'm just going to open back up Visual Studio Code, and then what we'll do is go to our index.html. So to make it look as close as possible to the JavaScript that I created earlier, I'm going to do a function, and I'm going to create a new function called random, which passes in a max. And then what you're going to see there is, in order to generate a number between 0 and 10, it's using math.floor, and then it's calling the math.random, and then it's multiplying it by the max. And when we do that, therefore, it's going to generate a number between 0 and the max number that I've specified, which is the equivalent to what I just created or is built into Pascal. Now what I'm going to do is going to create a function called add random number. We'll pass in A. And then what we will do there is we will say var b is going to generate a number between 0 and 10, which is the same as what we did before. I don't quite like what that's generated there. Boo to you, CodePilot. What we're going to do is just return b. So that will be fine. And then finally, what we will do is do exactly what we did before, which is add random number. And we'll add a plus b onto that random number. I will get rid of the type annotations that I put in earlier. So that is the equivalent JavaScript code to what we had before. Now, there's a few things that is interesting here. So if you think about this for a second, what I've actually done here is done a var b equals random 10. But if I was to separate that out, so let's do this. B equals random 10, then we're back to looking quite Pascal-y again, right? Because, if you think about JavaScript for a second and you think about things like hoisting and function scoping, then what happens with JavaScript is all variables get declared at the function scope level. Now, technically, if I put that var b underneath here, We know with hoisting, what would happen is that B would assign fine, and then it would jump back to the top there. In fact, we'll show you that in a second, but I'm not going to do that quite yet because what I want to do is just deploy that to Navigator. But if I look at that for a second while that's deploying, that var b equals random10 return b, that is pretty darn similar to Pascal. So if I actually, let's just put it kind of side by side for a second. You know, you see a var num integer, var b, you know, if I got rid of that integer, that's just going to be var num semicolon, that's going to be var b semicolon. In fact, let me make the, let's make this num rather than b for a second, just to make it a little bit more clear. Return num. You see num equals random10, and then of course it's doing the Pascal variable assignment rather than doing the return. Oh, that code is not exactly the same as it was. I could just do a plus num. Let me redeploy that there for a second. I mean, this is Pascal plus C. And this is sort of important because C doesn't have function scope declarations. It's not going to hoist things up to the top, right? C is, and the same with C# and the same with Java, is when you declare something, you know, the scoping is to the block. Pascal has block scoping as well, but there's, you know, there's no having to declare your variables in advance with C or Java, right? You can just declare your variables as and when you need them. This is very Pascal-y, right? And it's even using the var keyword. So very, very Pascal-y, and I think we sort of need to kind of recognize that influence. Okay, so now that that's deployed, you can see there that it's doing that sort of code calculation back in the JavaScript. And in fact, if I just do a reload, 659034444, whatever, right? So you can see that it's doing that random number. It's working in the same way as the Pascal code. And if you're confused why it's saying Fred, Bob, and 3 there, you know, it's because if I come back to Visual Studio Code there for a second, you can see I'm passing in Fred and Bob as my sum. And then what it's doing there is adding the random number. So it's doing a concatenation. Just because I forgot to update that there. So let's put 1 and 2 back there. But I think what I want to come back to this and do is show the hoisting piece for a second. And I want to show you the difference between Navigator 3 and modern sort of day JavaScript. So what I'm going to do is put the var num after here, because that's kind of hoisting. We know that that's going to, the way that JavaScript works, is going to pull that var number up to the top of declarations, and therefore it can do the assignment, and it's going to return the right value. So let's save that. I'm going to do a deploy, which will take a second. And that's deployed there. And if I do a fly open and I bring that up in modern JavaScript, you can see it's returned with a 9, and that's because of hoisting. Let's just come back to that for a second. So even though the declaration is here, hoisting pulls that up to the top, which, if you think about it, that's exactly what Pascal is, right? So if we come back into Pascal, you can see that, you know, I've got my declarations at the top before there. So is that any different from what JavaScript's doing from a hoisting perspective? And if we come back to how JavaScript's engine works for a second. So how JavaScript works underneath the hood, this is the V8 engine. What happens is JavaScript is going to take its source code, it's going to do a parse, it creates an abstract syntax tree. So you get this AST, and then the AST goes through interpretation, generates the bytecode, and then the bytecode gets converted to machine code via the compilers. That's how the browser handles that. If you think of Pascal for a second, and I'll show you this working, it does a one-pass compile, so it doesn't generate an abstract syntax tree like that. It just does a one-pass compile, and then it generates the bytecode, and then you can run it. So there's a little different. This is more C-like. This is how kind of C compilers do that, so I'm sure Brendan's kind of pulled from that. In the video that I show how JavaScript compilers work, one of the things that I actually do is I show the add two numbers example. So you see this function in front of you, which is adding two numbers. There's a number 10, there's a number 15. They're represented as constants, and then I add n1 to n2, and then we log it out. And what I do in that video is then I look at the bytecode that's generated from the V8 engine. So you can see it's done by the node --print bytecode. You can go and do this yourself. Again, go check out the video. It's on the top right hand corner. And then what you will see here, and this is probably the key thing that I want you to see, is if you you look at the top here, you've got this sort of parameter account. So parameter count 1, and then register count is 2. And those registers are N1 and N2. Because the way that the JavaScript V8 engine underneath the hood works is what it does is it assigns a virtual register to every single variable that you have within your function. So essentially, if I declare 10 variables or 10 constants, then what's going to happen is that register count will increase. So if you think about it, in order to generate the bytecode, now this happens after the AST is generated, but to generate the bytecode, what it needs to do is work out all of the parameters, i.e. declare them in advance and then do the registration. And then what you're seeing there is if you look at this bytecode is doing load into accumulator the number 10, which is the, the const 10, and then it's storing it into register 0. So that const 10 const A equals 10, and then it was const B equals 15. Then you can see that the A and the B constants, they're constant in this case, but it works the same for variables. They are stored in the equivalent registers, and then eventually they're added together. And of course, there's accumulator increment and happen on in between. But what that means is, let's come back to this for a second. What that means is that if I go into Visual Studio Code and look at Pascal, then Pascal is just kind of running a little bit ahead of the game there, because essentially what it's doing there is that it's declaring its variables in advance. And that's because Pascal's doing a one-pass compile. So by declaring the variables in advance, you can kind of work through that and you don't need to generate the ASTs. Whereas is what you can see with C and C++, and therefore JavaScript, because it's generating ASTs in between, you can have a multi-pass compile. So it doesn't sort of have that restriction, and therefore you can declare the variables sort of in advance. But there's still function scope. They're still different. Now, what that means for Pascal, because it's doing a one-pass compile, if I took this function here and then I moved it above the add random number, for example, and then I did an fpc hello.pp, I'm going to get an error, right? Because identifier not found add random number, because it's doing a one-pass compile, right? So that add random number needs to be before the sum. But that's not the case with JavaScript, because JavaScript is generating AST, so it's sort of leaning heavily on what happens in C and GCC, etc. So it's getting an abstract syntax tree, so it doesn't care about the order. It can work that out a little bit later. But it's still using optimization techniques, right? So that hoisting thing that I said, if I come back to my index.html, then yeah, I can move these functions around all I want, but Hoisting's case is that var is always going to be brought up to the top. And you saw that working when we did the fly open. So if I refresh that, you see I get different numbers. What is interesting though, is if I come back to Netscape Navigator and we just do a reload, I get an error. And it's coming back with function does not always return a value. And what does that mean? It means that hoisting wasn't there in that version, right? It needed that var to be ahead. I don't know how that evolved over time. I don't know if that was because the browsers then tried to deal with that, etc., on purpose. But it's an interesting point. And actually, Brendan Eich has something interesting to say about that. Brendan says, why does JavaScript do hoisting was a question. Why was the language designed that way? What was the inspiration? And he's like, let's top-down program decomposition for free, call before declare, blah, blah, blah. Hoisting was unintended. Yeah, the consequence of functional hoisting because no block scope. So he was basically saying JavaScript was a rush job, right? And so start using ES6 as let. So that's a really interesting one. So I'm coming to the end there. I'm hoping you're seeing the influence. There is more influences of Pascal. So things like type aliases that you see in TypeScript, that comes from the type keyword in Pascal. That's there. I'm not going to go into that. I may do that in another video at some point, but they are same. You can look at things like the with statement, right? I know we don't use that anymore in JavaScript. We're recommended not to use it, but Pascal has a with statement as well. So the influences are huge. And then again, even things like the use of sets and unions, etc. in Pascal, again, is the sort of thing that's coming, is used heavily within TypeScript. So there's a huge influence of Pascal in TypeScript today. Now, it's not to say that the other things are not useful. I think the other big one in TypeScript later on is standard ML. I will do a video on that. The influence on things like self, on things like prototype or hypercard, on click, etc. And I'm not downplaying the influence of awk or Java on the language, but I'm just saying that if I really think about it, the way that Java and awk have been called out, I just think that Pascal and C should be holding a bigger influence, because I think the influence that both of those languages have on JavaScript today, and especially on TypeScript coming up, is a bigger influence than Java itself. That's my personal opinion. Feel free to be wrong. But I think it is worth you, if you've never coded in Pascal, go check it out, right? Go have some fun. I might do a video tutorial on it at some point, but go have some fun with the language, because it's going to help you understand under the hood what's going on with languages like JavaScript or other languages. So as we move into things like ML, type inference, etc., having that base understanding of Pascal helps. Anyway, I hope this video was useful. Maybe it gives you a deeper understanding of JavaScript, gives you a deeper understanding of programming languages. Maybe it's interesting from a history point of view. But anyway, I hope you had fun, and I'll check you out in the next video.